Hello everybody, welcome to my channel. Today we have an amazing problem for you guys where we're going to be talking about populating next right corners in each node, right? So this is going to be a very good problem. So let's see what it's all about, right? So like I said, we're given a perfect binary tree, right, where all the leaves, right, are on the same level and every parent has two children, right? So that's very good. It did told us that what they mean by perfect binary tree, right? So all the leaves are on the same level and the parents, every parent has two children, right? So that's very good to know. Okay, um, so the binary tree has the following definition, right? So this is the definition. So we have a value, we got a pointer to the left child, the right child, and we have also a next pointer, right? And let's see what they mean by that, right? So populating each next pointer to point to its next right node. Okay, so if there is no next right node, the next pointer should be set to null. Okay, very interesting. Let me see. So we're given it the next pointer, right? We need to somehow point it to its next right node. Okay, so let's see. So initially, all the next pointers are set to null, right? So they're null initially. So now it's our job to find a way to point them to their next right node, right? So let's see. Okay, we kind of understand what they're asking for, right? Pretty simple problem statement. So let's go through the example so we can further, solidify the ask, right? So we're given, so we got this example here. Let's see. So we can see we get this perfect boundary here, and we can see after populating it, right? This is what we have here, right? This is the illustration that we have here, guys, right? So this is what they're saying here, okay? So how do we go ahead and solve this? How can we transform this binary tree, right, to this binary tree, guys? How do we do that, right? So we do that by changing the next pointer, right, of each node to point to its right next, right? So we have one points to null because null one doesn't have a right node, right? So that's why it points to null, right? So and then two has a right next node, right, which is 3, for example, right? But 3 does not have a a next right node, right? So and for 4, 5, 6, 7, right? They 4, 5, 6 have a next right node because 4's right next node is 5, 5 next right node is 6, 6 next right node is 7, but 7 does not have next right node, right? So that's what we have. We're pointing to null here, guys, right? So yeah, so how do we go and solve it? That's kind of the ask here, okay? We know that we need to do some kind of a traversal here, right? We need to traverse the tree and then make decision at every node, right? Where to connect and all of that, right? So that's what we need to do, okay? So, but which traversal do we need, right? Do we need a depth first search? Do we need a breadth first search? It's up to us to decide, right? So, which one can it be? So, I'm thinking for this problem, right? Since we're doing things, so because we need to point each node to its right next node, right? That means that we're going to be doing things level by level, right? Essentially, because we got to go at each level, connect every node to its next right node, right? And then after finish the next level, going to the next level, right? Doing it that way would make it a lot, very simple, right? And you guys know when we're talking about level by level, layer by layer, right? We use breadth first search, right? BFS. That's what it's good for, and that's what it's known for. And doing things layer by layer and doing things like that, right? So level by level. So because of that, so we process the first level, we go to the second one, and then we go to our right. So by doing that, we can for every node each level, right? We just connect it to since still be right next to each other, right? Because of the we're doing things level by level, so we can easily point it to its right next node, right? So let's quickly go into the drawing board, right? See how the breadth is going to be useful in this particular problem, right? So so I went ahead and copied everything here and I pasted everything here, okay? So this is going to be representing our queue, right? Because we're doing breadth search, we're going to be using a queue to help us in doing the traversal, right? Okay, so we have a queue, and also what we're going to need here, guys, right? We're going to need to, just to make it easy for you guys to see what's going on, so we're going to have a node variable, right? It's going to pretty much let us know which node that we're currently pointing on, right? When we start doing the walkthrough, okay? And also we're gonna have the size of the current level. Okay. So that we know how many nodes to process at that particular level, right? Just like we've done in the past before in our other breadth search problem, right? So so when we initially start, right, we put 1 to the queue, right? This is what's gonna kick off the breadth search guide, where we start at the root node. We put it in, right? And so now, since 1 is the only node at that level, right, we take 1 out, right? So the current node, right, that we have is this one, right? The size of the queue is 1, right? So it tells us there's only 1 node at that particular level, right? So I'm processing 1 node, right? So size of the level is 1, right? So I process 1 node, right? And it's 1, right? And now 1 does not have any right next node, right? So because of that, it's gonna stay the same, it's pointing to null. Okay. And next, guys, right? And we're gonna, before we go forward, right, we're going to be adding. Does it have any? Does it have any child, right? It does have children, right? As a left child and a right child, right? So because of that, we're gonna add those 2 in there. Okay. It has 2 child, right? So it's where we add 2 and 3 in there. Okay, so now we go on to this level, right? For this level, the thing's changing. Now we have the size is 2. There's 2 nodes at that level, and we take 1 node out, right? So now it's 2, right? And then we're gonna process 2. Okay. So now we check, does 2 have right next child, right? Yes, it does, right? Because it's not the last node of that level, right? It's not, right? Because it does, right? So its right next child will be in the queue, right? And that's why we're going to use the queue. The queue is going to help us and easily have access to every node's right, every node next right node, right? We're going to have access to that because as we're processing the node, right, we notice there's 2 nodes at that level, right? And this is the first node, right? So because this is the last node at that level, then we know that the next node that's in the queue has to be my neighbor, right? The next right node, right? That I need to point myself to. So because of that, we're going to just get that node and point it to, make it point to 3, right? And just like that, guy. And then before we go, we make sure we add our children as well, right? 4 and 5, right? And then I got 1 more node to process for this level, right? Okay. Now we take 3, put 3, right? And then 3 is going to do the same. 3 does not have a, because there were 2 nodes, and this is the last node at that level, right? So it's not going to be pointing to anything, right? So it's going to be pointing to null, right? Like before, guys, right? Okay. And then we do the same thing, guys, right? We go into the next, make sure that we add 6 and 7, right, to the queue, right? And so after doing that, we do the same thing. We process everything the same way, guys, right? So now when we start processing the last level, now the size of the queue will be 4, right? That meaning there's 4 levels at that 4 levels at that level, right? So now we just take 1 node out. Okay, we take 1 out of the queue, which is 4, right? Take 4 out. And we do the same thing, guys, right? We know it's not the last node of this level, right? Because there's 4 nodes, and this is actually the first node, right? So we make it point to the next node in the queue, right? That's why the queue helps us keep the ordering, right? Which is pretty good, right? So we point to it automatically, right? So we point it like that, right? Then no children, obviously. So we go on to the next one. So now the node is 5, right? So now 5, the next node is 6, right? It points to 6. And then, no children, so 6. Then 6 points to 7, right? Because that's its next node, right? So that's why it gets to point to 6, right? And just like that, and then by the time we get to 7, because 7 is the last node, right? Okay, because it's the last node, it doesn't point to anything. It points to null, pretty much, right? So that's pretty much it, guys. So let's the code is gonna be even more simpler than the walkthrough, guys. So let's quickly get into it real quick. Okay. So let's get better. So now we said that we're gonna be using a queue to help us in doing the traversal, right? Because we're doing the breakfast search, guys, right? Okay. So now we're gonna start at the root node, right? And start our algorithm, right? So which is queue is not empty, right? We get the size of that particular level, right? Get the size of this level, which is captured by getting the size of the queue. Okay. And then we're going to process all the nodes for that particular level, right? So how do we know how many nodes we need to process? It's done by with the size variable that we have here, guys, right? Okay. So now we're going to process X amount of node, right? Which is, size, right? So process first lever is going to be 1, right? Because it's the only node, right? At this level. So we're going to call this root node is equal to queue.pull. Just get it out the queue. Okay. Just like we're doing. And then we're going to check, guys, right? Is this the last node in the queue, right? So how do we make sure that we get that, right? We just do this check, right? Is it equal to, is it less than size minus 1, right? If it is, right, it's not the last node, right? At that particular level, right? If it's not the last node, then what we're gonna do a node that next pointer, right? The next pointer of that node, make it point to whichever guy is in the queue, right? So because I'm not the last node in that level, so I know I must have a node to point to, right? Which is on the same level as I am. Okay. And then we're gonna do a check, guys, to add our children, right? So we're gonna do a check for the right child. So if it's not equal to null, we make sure that we add it for processing as well, right? Because we need to process them as well, right? And we do the same thing for the right child. Okay. No child left behind. Okay. After we do all of that, I think we are in good shape. Okay. Yeah, all right. Make sure I'm not tripping. Okay. After that, we can return the root, guys, right? The root will be, return the modified binary tree, right? So we start off at the root node, right? And then we process everything. And we do things level by level. We capture the size and process all the nodes for that level. And then we check if it's not the last node, then we know that we could point to whatever node's in the queue currently, right? We use queue that peak, right? We don't get it out. We just get the peak, right? And we just peek at it, and then we point to it, and then we add our children. And just like that, I think we are good. Looks good to me. Let's press submit. Bruh. It seems like I forgot to add a check for all conditions. So let's see if we passed it this time. Awesome, guys. We're able to pass it this time, right? So we're able to pass all the test cases. So if you guys found value, you guys enjoyed this video, let me know that in the comment section. If you're new here, subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.